Hello, everybody. Thank you for coming today. This is going to be an introduction to SIG API machinery. My name is Federico Bongiovanni. I'm an engineering manager at Google. I was a user of Kubernetes before becoming involved in the other side of the coin and helping Kubernetes grow. So it's been a really interesting journey for me. I'm very proud to be part of this community. I was making fun with my fellow SIG members here that the deep dive for API machinery just happened before this one. So if you have deep questions, you can ask the people that just gave the talk at the end of this one. Very good. So it's going to be an introduction. Sometimes we are going to stay high level. Sometimes we are going to go low. We will have time for questions at the end. Basically, this is what we are trying to cover today: an introduction to the SIG, an explanation of what things we own, a clear list of things that we don't own that sometimes are misunderstandings, why SIG API machinery is so central, so important, and sometimes, this is true, so hard. It's so hard to ramp up. It's so hard to contribute. And then, some accomplishments. What did we do for you lately? What is our roadmap, which is super packed. And then hopefully you will learn about some opportunities where you can join us, just maybe quietly, join our meetings, hear what we do, what do we talk about, and if you want, start helping us, contributing, and learning from the experts. Very good. So high-level overview. Everybody knows what a Kubernetes cluster is, hopefully. There is a part of the cluster that is called the master nodes. There is another part of the cluster that is called the user nodes. There is a persistence layer that is etcd, in the case of Kubernetes. Master node talks to the nodes. Master node, AKA Kubernetes control plane, talks with the persistence layer. And today we are going to talk about these guys and a little bit about these guys. This is what SIG API machinery is about. What runs in the master nodes usually is also known as the Kubernetes control plane. So first question is API machinery equals to all the Kubernetes APIs? Common misconception. No, it's not. So when you have a question about a particular API, we might know about it because we use Kubernetes, but we definitely are not the owners of that. We don't test it usually, individual APIs. We don't know everything about those APIs. Still, we do own some of the APIs that belong to our machinery and that allow you to interact with API machinery mechanisms, and we are going to talk about them a little bit further. So following our charter, SIG API machinery is responsible for the development and enhancement of Kubernetes control plane. The scope covers API server, persistence layer, etcd, controller manager, cloud controller manager, custom resource definition, and webhooks. There is a link to our charter. In other words, API machinery is the generic technical stack that allows you to interact with a Kubernetes cluster, talk to all the individual APIs, and extend the Kubernetes API. So remember this picture. We are going to focus a little bit of what's going on inside of this one. You can go to our charter, again, and get a very detailed list of things that we own with component names. In other words, trying to make it a little bit more readable, basically we own API server, obviously. We own the controller framework, but we don't own all the individual controllers. Very important. We do own some of them because they are part of the machinery. But then, every Kubernetes resource or Kubernetes other areas that they build the controllers, they use our framework. We don't own those. We own the client generators, and specifically Client Go. Client Go is an area where a lot can be done if you want to help us, for example. Basically because Client Go is used internally. for internal communication. So whenever you have to use client Go, the documentation is very poor. The examples are not super clear or super basic. So I have a funny story about somebody that is not here, but works in the office with us. And he was, coming like 4 or 5 times a day and speaking for like half hour with members of my team just to understand how to use the client Go, right? So after that, we did some follow-ups. We did some improvements in the documentation, but there is a long list of things that can be done there if you're interested. So, and a list of things. I think one of the most important ones that everybody's talking, and I'm going to mention a little bit, is the extension mechanism, which in 1.16 went GA. So you heard about CRDs, you heard about admission webhooks, super important, and we will talk a little bit about why it's so important. This is a schema that Stefan here created for a KEP. Explains a little bit how is the life of request coming through our machinery. You see that it's a complex diagram, a lot of layers. And I think one of the things that is very important to remark is that Kubernetes, through API machinery, allows every user to extend the Kubernetes API through CRDs and admission webhooks. And after doing that properly, Kubernetes will treat your custom resources as first-class citizens, the same level of a pod or deployment, things that come out of the box with Kubernetes. And this is one of the things that blew my mind when I learned about it a couple of years ago. And then I had the privilege of being involved into bringing this to GA, because I come from a world where you build applications, and if you want applications that expose, for example, REST APIs, and you build the binary, you deploy it in some application server or web server, and the API is there, but then, for example, let's say Tomcat has its own API, if you want to say, it would never allow you to extend it. And if you extend it, it would be like super weird. Doesn't it sound like super awkward? But Kubernetes broke that paradigm and allows you to create, to extend the API, to the point that being the manager of API machinery at Google, I had conversations with teams in and out of Google about using the API machinery, API server, for things completely not related to Kubernetes, which is crazy, right? And there is a very good talk from the tech lead of the SIG, Daniel, who is here, about we ended up creating an API server, not only for Kubernetes, works in Kubernetes, but also it's a generic API server, very powerful one. Did you know, because we think that we are important, we own approximately 25% of the code of Kubernetes. I'm talking Kubernetes/Kubernetes. So if you think about that, it's a big piece of the code. And the cake is blueberries. I wanted to match the blue of Kubernetes. This is a quote that I really like, and I think illustrates a little bit the theme of this talk. Kubernetes is not just API-driven, it's API-centric. Brian Grant, for those of you who don't know him, is one of the creators of Kubernetes, together with everybody that was, the other 6 that were yesterday in the main stage. So more or less, you get an idea of what do we own. Let's talk a little bit about what we do not own. Easy, right? The other 75% of the code and all the things that people build on top of our machinery. If we remember that quote from a previous slide, this is a list of the things that we don't own. So as I said, we don't own all the individual Kubernetes APIs. Each API is owned by its own SIG or working group. It's an interesting topic if you're involved into this, because there is a number of discussions in the open source community about, for example, API compatibility between Kubernetes minor versions, and who is responsible for guaranteeing that we don't break backward compatibility, or even worse, forward compatibility, or even worse, which is probably one of the most scary things that could happen, not changing compatibility in the APIs, but changing behavior in the objects that you are using, right? So what I can say is API machinery in general, we don't own that part. Although we are part of the ecosystem and we are interested in helping to solve that problem. But it's a problem that has to involve the entire community. We don't own most of the controllers, as you can deduct from the previous statement. We usually don't own the operational characteristics of your cluster. We get a lot of questions. I'm going to put in the last slides a number of links to the Slack channel and the mailing list. You're always welcome to come and connect and ask questions. The individual failures of your cluster and the reasons why it's failing, we can try to help. Sometimes they depend a lot on the context and the environment where you're running and what you are doing with your cluster, what things you have installed, how are the network topologies or the machines that you're using, etc. Next one is a hot topic. We don't own your particular API review. We are API machinery. Some members of API machinery are kind enough to be API reviewers, but API reviews is something that API SIG architecture owns, and they have their own process. You can connect with Jordan if you're interested in learning more about that, but we are not the owners of that. You can feel I'm pretty defensive on this. It's not the intention. It's just that API machinery is so generic and vague, if you want, that if you don't set clear boundaries, we end up owning like the entire cluster, and that is, it's not going to be good for anybody. And then we don't own all the tooling and mechanisms that use our own mechanisms to extend APIs, right? Okay, so this is a little bit of learning. Why is so central and important and hard? Picture of a cluster in the center of everything. There is an API server. You know that in the control plane, I just listed like 2 minutes ago, we own a number of components. Some of the most important ones are probably the controller manager, the cloud controller manager, the scheduler, and then there is others, but those are the main ones. There is a number of things that you can do to your cluster to extend it. Some of them may run in the master nodes. Some of them, like webhooks, could be running somewhere else. I put them in the cluster, but they could be also outside of the cluster. Then there is the nodes. And then there is everything that wants to interact with the cluster. I forgot to mention, probably you know it, the fact, and this is where I link it with the quote from Brian Grant. Kubernetes is API-centric, which means that even these components from the master node, the controllers, or the cloud controllers, they are not allowed to speak to each other. Nobody can talk to each other. All the communication is done through the API server. The API server is the one that knows what needs to happen before a message or an event can be persisted or broadcasted to the rest of the controllers. I also didn't put in this diagram because, funny enough, I ran out of transitions to do these animations, but there is a CD who also only talks with API server. An API server only talks with a CD, so nobody else can talk to that. So let's go there. Let's go back to where we were. And this is users, and users are sometimes a human, sometimes is a client, sometimes is a human doing kubectl get pods, sometimes is a Python client as part of Jenkins, continuous deployment pipeline, trying to deploy something to the cluster. So all these guys, all of them, they have to go through the API server. So you can imagine how important it is to have an API server that is robust and doesn't break. If you have run clusters in production, you may know that API server could go down, and the cluster and what is running on the nodes for some time will survive. That sometime it's undefined. It depends a lot on how your cluster is configured and how it's running. Probably will survive a couple of hours, but as soon as something goes wrong in the node, something needs to be reacted. If API server is not responding, you're going to get into troubles. And this can grow, right? So you can have a lot of nodes. If you go to the talks from SIG Scalability, you may have heard that we are trying to push the boundaries of how big a cluster can be. I don't know the exact numbers, but it's in the tens of thousands. So you can imagine that how complicated gets the reliability of a cluster when all these kubelets are trying to synchronize state, and when scheduler is trying to tell API server to go and replicate these states so it can be replicated across the nodes. Same thing with the users. The number of users and the clients trying to talk to API server can increase. This is another view from a talk from a previous KubeCon from somebody here in the audience. But it's the same. Like API server is at the center of all these components. And I wanted to include this to highlight this. Like controller manager talks to API server, but at the same time, controller manager is not a component. Controller manager is talking to all the controllers. This is the controller framework, right? So. And then there is the custom controllers that you create as part of your CRDs and extensions. So yeah, there is a lot of traffic going through this guy. I mentioned this. We are the API server is the only one that talks to SCD. So going back to this picture explains why we think that we are important. Because we are, basically. API server is probably one of the most critical pieces of the cluster. OK, so dramatic, this name. Very good. So let's get out of the dark zone, and let's say that, given all these things, what did we do lately? I think it's a super good story that we have in 1.16. CRDs were finally promoted to GA. It's been a journey for more than 2 years with a lot of people from the community involved agreeing that CRDs was the way to go. I recommend you to, when you go back home, to listen to Eric's Toon talk, was earlier today. He did a very extensive analysis about the Kubernetes resource model and the usage of CRDs across GitHub and how the adoption has been growing. There was a graph that was really promising. And I wanted to highlight this because there was a lot of, it's a super complex technical problem. There was a lot of back and forth in the community until we finally agreed on what was the right technical direction to go and what was the exact way that we were going to allow versioning of your CRDs and conversion between versions. And then all the cascading, you can imagine, that is it's a core component, and then it starts cascading to all these frameworks and applications that use CRD to be able to adapt this. For example, Kube Builder. So very interesting. And very tied to that was admission webhooks, which also was in beta for probably more than 2 years. This is probably one of the most powerful Kubernetes features that I have seen, the ability to extend and mutate the behavior of your cluster. The other one that I'm super proud is apply server-side. For those of you that are not familiar, when you do kubectl apply -f and some configuration, most of the logic and the validations happens on the client. It's not that bad. The problem is looking at the future, how does it constrain or helps keep a consistent story for the ecosystem of clients around Kubernetes. Imagine that if somebody is using kubectl apply and the validation and the logic is happening on the client, now we have to replicate that logic to all the clients around the Kubernetes ecosystem. So it's really, really needed. That said, Antoine Pellis is here, who is one of the main drivers of this feature. It's a it's very ambitious to try to change something that is so core to the execution of something that everybody does every day multiple times, that was scary at the beginning. Making it to beta was really, really encouraging and important. We still have a long way to go. We are dealing now with basically performance, because what was happening on the client now is happening on the server. And in order to do that, we had to change the model of the objects, because now the changes can be applied concurrently, and we need to maintain clear ownership of the different fields of the object, so nobody's stepping on top of each other. So the objects are bigger, serialization and deserialization changes. So yeah, basically there is a lot of work to do. So I encourage you to give it a try, give us feedback. I'm jumping a little bit ahead, but server-side apply has its own working group as part of API machinery. So it gets together once every 2 weeks. You can come. I have a special place in my heart for that group. I saw, particularly in that work stream, at least 5 people coming from nothing. I'm here to listen, to actually becoming members and owners of some of the parts of the repo and contributing to API machinery. So yeah, it's a very good place to start if you want. And then we have a bunch of other things that we've been moving forward: storage migrator, network proxy. For those of you who don't know, API machinery owns something that is called SSH tunnels that has been deprecated for a while. We are trying to get rid of it, and to get rid of it, we are pushing forward another project that is called network proxy to replace them. We did a bunch of work to stabilize metrics. If any of you runs Kubernetes in production and you have some kind of pipeline for your metrics and visualization charts, you will notice that sometimes version to version, the metrics break or the charts break, because metrics were a little bit of loose definition. So basically what we are pushing forward is a cap for metrics stability that in short says metrics should be treated as APIs. So you want to get rid of a metric, well, you have to deprecate it and wait a couple of versions and let everyone know. You want to push a new metric, so you will have to go through alpha, beta, and make it to GA. I think that is super positive. What else? So we don't own etcd. If you're interested in etcd, etcd is a separate project, has its own repo, its own community, but we are very close friends with etcd. Basically because we are the only ones that talk with etcd, because etcd is basically a guest in our house like all the time. He's in our guest room all the time. etcd is related to performance, is related to upgrades and downgrades of the control plane. So we are very close to the etcd community. We helped the release of etcd 3.4. etcd 3.4 comes with a lot of improvements, especially in performance, when we were talking about how big a cluster can be, and other things. For example, allowing you to add no non-voting members to an etcd cluster. So the cluster can be upgraded in pieces without compromising the integrity of the data. And then as part of this, we added a bunch of conformance tests. So pretty proud of that. Conformance is an interesting area too. What do we have for the future? So as I said, we are trying to deprecate SSH tunnels. There is a cap. There is a prototype. You can come and help us there. Super interesting. I don't know which companies you guys work. You might be using or not SSH tunnels. This is interesting for you. I already encourage all of you to come and participate from server-side apply. There is a lot of things that you don't have to be an expert. There is documentation that needs to be done. There is tests that can be improved. There is a lot of things that you can come and do. If you or you can have the opportunity of watch the deep dive. We are really trying to get into priority and fairness for API requests. As you can see from the previous graphs, API server is at the center of everything, but sometimes it's not the external clients or users that are trying to get API server to actuate on something. The controllers are competing for API server resources. So how can we make sure that a malfunctioning controller or a controller that is, configured in an awkward way is not taking all the bandwidth of API server and then bringing it down, causing an outage for the cluster. So this is a project that is complex enough. We are working on this one. And then the work for CRDs didn't finish with GA. There is a lot of work that still needs to happen. One of the other working groups that belongs to API Machinery is KubeBuilder. KubeBuilder, if you don't know it, is the framework or runtime that helps you use CRDs and generate, scaffold all the controllers based on the resources that you're defining. So they get together once a month. You can also participate in that one. And then we have Stefan here and Joe. We are working on immutable fields. Also, you can learn more about that in the deep dive. And in the end, we have 28 open KEPs right now that are tagging API machinery. So you can see how much people is getting interested in the center of Kubernetes and trying to do things, which takes a lot of our bandwidth. We do it with a lot of joy. Sometimes, we wish we were faster. We wish we had more people to help us. We don't, so we do the best we can. Yeah, basically, this is a little bit of our roadmap ahead. How can you get involved? I wish I had a better, more organized answer. Like we have this program for beginners, this for intermediates. We don't yet. I have the commitment of working on that next year. Well, next year is, we still have a couple of weeks this year. What I can suggest for now is, if you're interested, any of these topics or things that I've been saying rings a bell, awakens your interest. These meetings that I'm going to list here, they are open. Nobody is going to put you in the spotlight. There is a lot of people that shows up and just listens. The SIG gets together every 2 weeks. There is an agenda. You can add your topics, or you can see the topics that people is going to discuss, and then see if it's interesting for you or not. These meetings are recorded also. There is next slide will list the YouTube channel where all these meetings are there. The next one for me is super interesting. It's very low bar to get in. We get together twice a week for 30 minutes, and we go through everything that was created tagging API machinery from the last meeting. So this includes pull requests, open issues. We go through them. We try to understand, what is this pull request? What is this person trying to merge into the repo? Sometimes there is interesting discussions. Sometimes there is follow-ups. For the people, if you ever join one of those meetings, sometimes people, it's like, oh, this issue is interesting to me, or this happened to me, or I want to learn more about, I don't know, client Go, or any other thing that is being tagged. So they add they CC/CC their GitHub handle, and then you get the notifications on the issue. You can see the discussion going on, the code that is being changed. I think it's a way to learn. We also try to be good and tag the ones that are, in the Kubernetes community, there is this good first issue or something that is the tag. So you can also try to query what is labeled API machinery and is labeled first good issue. Take a look to them. Nobody's going to bite you. You can come to the channel and ask, if you think you have a solution or not. My humble recommendation is probably at the beginning, what is going to happen is somebody of these guys is going to say, hey, looks like you have a good intention here, but we need a test, or what is this fixing, or what is the motivation? Sometimes people is not very good at providing context, but all those things are workable. So don't be afraid. And then there is the working group meetings. Those are recorded, so you can look at them. You can see that we don't bark or bite, so it's very friendly meetings. You can come and join. Yeah, basically that. And I really hope that the next year we are going to have something more formal. We have an issue with API machinery, which is the ramp-up is going to take you some time, depending on your dedication, but can be from 3 months to 6 months. And we are committed to help people ramp up. What we need is commitment on the other side that people is not going to walk away because this is basically open source. People invest from their heart, their effort, their knowledge to helping everybody ramp up. And then if you disappear, that doesn't go anywhere, right? So we are a little careful of being overly open to say, yeah, come and sit with me for 4 hours and I will explain you everything. But it's doable, and we are committed to that. We have a big SIG. If you go to the meetings, you will see that in the bi-weekly meetings, we have around, between 15 and 30 people, depending on the topics. The list has more than 500 people subscribed. The deep dive was packed before this meeting. But we need more people to help us. There is a lot to be done. And these are a couple of useful links. We have 2 chairs. I recently became one of those. We have 2 tech leads. One of them is here. The other one is David, who is back in the East Coast right now. And then you can see our homepage, our charter, our Slack channel. It's very active. You can ask questions all the time. Somebody's going to answer them. The YouTube playlist and the mailing group. If you subscribe to the mailing group, you will get an automatic invite to all these meetings I was saying. So, easy peasy, right? And before I forget, if you're interested, I have some pins from API Machinery here from the Contributor Summit, so you can come and get some. And with that, that is all I had. I believe we have some time for questions, if anybody has a question.
Do you help control the runtime as well?
Yes. It's part of, yes.
There's also a sample controller.
Yes. Anything else? No? Don't be shy. Well, if you're shy, we can end this and you can come and meet us in person. Thank you, everybody.